Today, we're going to talk about a programming language that's, well, one of the oldest out there, but its ideas, they feel like they could have been invented yesterday. We're talking about Lisp. Okay, so if you've ever seen a snippet of Lisp code, your first reaction is probably something like, wow, that's a lot of parentheses. I mean, they are everywhere. It's a look that's instantly recognizable, and maybe just a little bit intimidating.
And yeah, that look has definitely earned it a nickname or two. The most famous one? Lost in stupid parentheses. It's this classic joke in the programming world, right? But honestly, it's also kind of been a wall that's kept people from digging into what's really going on inside all those brackets.
But what if those parentheses hide a secret? An idea so powerful, so fundamental, that it ended up shaping almost every single programming language you use today. Well, that's exactly what we're going to explore.
To really get Lisp, you've got to go back in time. I'm talking way back, to the very dawn of artificial intelligence. Back when computers were, for the most part, just seen as these gigantic room-sized calculators.
So picture this. It's 1958 at MIT. A researcher named John McCarthy is working on AI, and he's got a problem. The languages they had back then, like Fortran, were great for crunching numbers. But AI isn't about numbers. It's about ideas, logic, symbols. Fortran just wasn't built for that. So McCarthy looked to something different for inspiration, this pure mathematical concept called lambda calculus, and he designed a brand new language from the ground up, publishing the paper that started it all in 1960.
And this is where we get to the real magic of Lisp, the part that changed everything. You see, it wasn't just another programming language. It was built on a core principle that was, frankly, revolutionary.
Okay, that brings us to a word that sounds super complicated, homoiconicity. But trust me, the idea behind it is incredibly simple and elegant. All it means is that, in Lisp, the code you write is just a piece of data. That's it. Specifically, it's a list.
So think about that for a second. That factorial function we saw at the beginning, to the Lisp system, that's not some special, sacred block of text. Nope, it sees it as just a list that contains other lists, symbols, and numbers. And since Lisp was built from the ground up to be amazing at manipulating lists, that means Lisp is amazing at manipulating its own code.
And that is what makes Lisp macros so incredibly powerful. See, in most languages, a macro is just a simple text replacement tool. But in Lisp, a macro is a full-blown function. It runs before your main code, takes your code as its input, transforms it however you want, and then spits out brand new code to be executed. You are literally writing programs that write programs.
And the crazy part is, that wasn't even all of it. Lisp was just this hotbed of new ideas. Automatic memory management, garbage collection, that was a Lisp thing. The whole if-then-else structure we all use, Lisp. Dynamic typing, yup. That interactive command line, the REPL that developers live in today, Lisp pioneered that too. So many things we just take for granted now got their start right here.
So, with all these groundbreaking features, it's really no surprise that Lisp became the absolute heart of the AI universe for decades.
I mean, seriously, for decades, we're talking the 60s, the 70s, the 80s, if you were doing serious work in artificial intelligence, you were almost certainly doing it in Lisp. It was the language for symbolic reasoning, for building expert systems, for figuring out natural language processing.
And a whole world grew up around it. Famous AI systems like Shrudlu, this program that could understand commands in a virtual world, were built in Lisp. The language was so powerful and so different that they even built special computers just to run it. They were called Lisp machines, hardware designed specifically to run Lisp code as fast as humanly possible.
But nothing lasts forever. The AI winter hit in the late 80s and 90s. All that funding for AI research just dried up. And at the same time, the rest of the world was moving to cheaper, standard hardware running languages like C and later Java. Lisp's time in the spotlight, well, it started to fade.
But here's the thing about great ideas. They don't just die. The story doesn't end there. Lisp's influence didn't vanish. It just changed form, finding new ways to stay relevant.
Right around the turn of the millennium, a new wave of programmers started looking back. Influential thinkers began writing these essays about the forgotten power of Lisp, and a whole new generation started to look past those parentheses and realize, whoa, there's something really special here.
And that brings us to today, where Lisp isn't really one single language anymore. It's more like a family. You've got Common Lisp, which is the big industrial strength version with everything you could possibly need.
Then there's Scheme, its super minimalist and elegant cousin, which is a favorite in universities. And then you have Clojure. That's the modern take, built to run on the Java virtual machine and designed from the ground up for today's multi-core world.
But here's the real twist in the story. Lisp's greatest legacy, its ultimate victory, isn't in the languages that still carry its name. Its real win is that its best ideas are now everywhere. They're hiding in plain sight, inside the tools you and I use every single day.
Just think back to that list of innovations for a second. Garbage collection, treating functions like any other piece of data, dynamic types, interactive development loops, metaprogramming. This isn't some old, dusty list of features. This is basically the blueprint for modern programming. Let's make this concrete. Every time you write a line of Python or Java or JavaScript and you don't have to worry about manually managing memory, you're enjoying a luxury that Lisp introduced to the world.
Or how about this? Every single time a JavaScript developer passes a function into another function, a callback, that's a core functional pattern. They are using a concept, first-class functions, that was fundamental to Lisp's design from day one.
And the spirit of Lisp's most mind-bending feature, macros, the idea that a language shouldn't be rigid but should be something you can extend yourself, that very idea lives on today in the metaprogramming that makes languages like Ruby and Elixir so powerful. So in the end, you might not be writing Lisp code every day, but its ideas, its philosophy, its ghost is in the machine. It proved that a programming language doesn't have to be a static set of rules. It can be a dynamic tool for thinking. And that leaves us with a pretty big question, right? If Lisp's core idea is true, that code is just data, something we can shape and rebuild, what incredible new worlds are just waiting for us to build them?